Using a digital control circuit for positioning, actuators of any type can be precisely controlled. Let's look at a simple circuit that will provide linear motion to a positioning table. The table begins at a binary home position of 0000 and is known with the gray code absolute encoder attached to the motor shaft. To move the table to position 5, the operator inputs a numeric value of 5. After the input is received, the flip-flops in the circuit are reset and the equivalent binary number of the user input is loaded into the 4-bit storage register. After the desired position is received, the magnitude comparator compares the 4-bit input A from the user input to the 4-bit input B of the encoder feedback. If A is larger than B, the A is greater than B output is activated. If B is larger than A, the A is less than B output is activated. If A is equal to B, the A is equal to B output is activated. The outputs of the magnitude comparator are input to the amplifier. Amplified potential is transmitted for positioning of the motor. For example, if the A is less than B output goes high, the op-amp inverts the plus 5 volt signal to minus 5 volts. As the minus 5 volts is applied to the summing power amp, it is amplified and inverted to positive potential. The output of the summing amp is applied directly to the DC motor of the actuator. Positive potential provides clockwise rotation, and negative potential provides counterclockwise rotation. The encoder attached directly to the motor shaft provides real-time feedback of the actuator position in gray code format. Gray code is converted to binary values to maintain a common numbering system for comparison and is input to the magnitude comparator. Conversion is achieved using 3 exclusive OR gates that change gray code to binary format usable by the magnitude comparator. Looking at the complete circuit, we can see that by entering the number 5, the A values are compared to the B values of the comparator. Amplified potential is transmitted to the actuator until the binary converted input is received by the comparator. As A becomes equal to B, the light turns on to verify the final position has been reached, completing the cycle.